Today we're going to be using AWS components in our robot. On my desk here I have what are the guts and the makings of a robot. Here I have a speaker and a Intel RealSense D455 camera. I have a LiDAR back there, a re-speaker, and this is the 4 microphone array. Got some models of different components. This might be a wrist or it might be the neck, I don't know yet. This is just we had this for a long time, basically to demonstrate how to follow a face and various directions from the input. And back there I have my handy dandy Jetson Xavier, and back here I've got a JetBot, if you can see that hiding back in the back. But we're going to focus today on the screen. So first thing you should notice is that we are in the NVIDIA desktop. I am running the latest Jetpack, and I'm also running ROS2 Foxy. So what I have here are a few simple nodes, and we won't go into detail, but very simple. So it's a node that's catching the speaker, and then we have a node that deletes files on an interval, and then got some weather, got some other things here. There's an S3 managing node as well as the transcribe manager. These are all just straight up nodes. Nothing special, no actions, none of that. So first thing we're going to do is run the node so you can see what's going on there. So I've got up here, run it. And while that's running, I got the dryer going in the background, sorry about that. We're going to record what I say here. So as you saw there, and it's going to do its thing, it listed all of my buckets that went off and said, okay, I've got your file here, which is this thing right here, and I'm going to process it. It's taking a bit of time, probably too much time for a robot, but you can see one of the interesting things here is that it was able to go ahead and eventually transcribe that file. Of course, you want the robot to be much faster, so we're going to definitely do local speech to text, and then we'll do further processing with the AWS Transcribe environment. And what I mean by further processing, I mean we're going to do things like speaker diarization. We want to know what a speaker is saying when they're saying something. I just want to go back to this for a second, just so you can see what's going on there. So we have the file. It's been, well, let's go back a little further so you don't see the error there. Looks like an error, but it's not. Just really, I just stopped the node from running. What you can see here, it actually created a job, and you're going to see that in a minute when I show my my console. You see, it created this job. It found this actual file and transcribed it, and then put the results into this link here, which is available as a signed URL. So a bunch of stuff comes back here, tells you how many times it tried to transcribe the file, tells you how many speakers are in the file. If you'd like, I think right now I have it set to not do that, but definitely can do speaker channel identification. It's set to false, but I can set that to true. And that's kind of what I want, because I want to have the diarization actually work. Okay, so let's shoot on over to here. And we can see here is my console, and nothing magical in here. But what you'll see here is that a job started on its own and just completed. As a matter of fact, let's just run it again so we can just have many jobs just run, so you can see that running. But what you see here is that as I say things and I record and I do those kind of things, eventually what happens is the recording is transcribed and the actual text is now presented back to me. You can see here it says not ready yet, not ready yet, but eventually you'll see another one pop up here as the job completes. Still not ready. It's getting there. And what we would do with this ultimately is improve our speech to text locally. So we would improve the model that we're using and the patterns of speech by using the results from here. So let's go ahead and refresh and see what happened. All right, so we've got a bunch of new files here. Here's one. This one's in progress. You can see here the output URL is not available yet. There's going to be many more because I'm still speaking. And look at that, it's done. So I don't know exactly what I said, but I can download the full transcript, as you can see up top there, and delete it. I can also, I must have said something like, is approve RA speech? No, I don't think I said that. But if I did, well, then it just didn't. I'm just not that great of a speaker. Okay, so if I were to integrate this in my application, just as it is, this is a simple, job name, the type of code that this is the input file and example API, and this would be the results coming out of it. Okay, I think that's good enough for today. And this can definitely augment what I already have in the local speech to text. One thing I would do is obviously run this on a separate worker thread or a separate node so as to not mess with the running robot, because we want the robot to actually be fast and do its job. So this sounds like what it would be for me is a verification of that the robot's understanding what we're saying to begin with, as well as an update to the model. So we'll use the transfer learning process to improve our model. Okay, good enough for today.